Have you ever wondered why our Earth looks the way it does? Why are there mountains, valleys, and plains? These intriguing questions may have crossed your mind as you marveled at the diverse landscapes of our beautiful planet. The answers lie in the fascinating realm of geological phenomena, natural processes that have been tirelessly shaping the face of Earth for billions of years. From the towering heights of Mount Everest to the sprawling expanses of the Grand Canyon, each topographical feature tells a story of the geological phenomena that crafted it. These phenomena are not merely ancient history. They continue to mold our world even as we speak in a dynamic dance of creation and destruction that has persisted since the dawn of time. Geological phenomena are the architects of our planet, employing tools of immense power and precision. These tools include tectonic movements, which create mountains and rift valleys, volcanic activity, which builds islands and reshapes landscapes, and erosion, which carves out canyons and shapes coastlines. Each of these processes plays a crucial role in sculpting the world as we know it. But geological phenomena do more than shape the physical world. They also have profound impacts on the biosphere, influencing the distribution of species and the course of evolution. They shape our climate and weather patterns, and even play a role in the distribution of natural resources, which in turn shapes human civilizations. So, the next time you stand atop a mountain or gaze out across a vast desert, take a moment to consider the geological phenomena that made it all possible. These natural processes are not only responsible for the world's physical beauty, they also hold the key to understanding the intricate web of life that our planet supports. To truly appreciate the complexity and grandeur of our world, we must delve deeper into the understanding of these phenomena. And that's exactly what we're going to do. So, buckle up and prepare for a journey into the heart of our planet's mystery. To understand the world around us, we need to delve into the fascinating world of geological phenomena. Imagine the surface of our planet as a giant jigsaw puzzle, continually moving and interacting. This imagery helps us understand the fascinating concept of plate tectonics, a theory that revolutionized our understanding of Earth's geological behavior. Picture Earth's crust and upper mantle, collectively known as the lithosphere. This lithosphere is not a single unbroken shell, but is divided into several large and small pieces, each called a tectonic plate. These plates, like pieces of a jigsaw puzzle, fit together to cover the Earth's surface. But unlike a finished puzzle, these pieces don't stay put. They're constantly moving, albeit at a pace slower than a snail's crawl. We're talking about an average rate of a few centimeters a year, comparable to the speed of your fingernails growing. Now you may wonder, what propels these massive plates? The answer lies deep within the Earth, in the hot, molten rock of the mantle. Convection currents in the mantle, driven by Earth's internal heat, push and pull at the plates above, setting them in motion. This constant motion has profound implications for the Earth's surface. When plates collide, they form mountain ranges like the Himalayas. When they pull apart, they create gaps where molten rock can rise and cool, forming new crust at mid-ocean ridges. And when one plate slides past another, the tension can trigger earthquakes, like those we often experience along the infamous San Andreas Fault. Volcanic eruptions, too, are a result of tectonic activity. As one plate is forced under another, in a process known as subduction, it melts and forms magma. This magma can rise to the surface, resulting in explosive volcanic eruptions. So the next time you climb a mountain, witness a volcanic eruption, or feel the earth shake beneath your feet, remember, it's all part of the grand dynamic dance of the tectonic plates. And so the ground beneath our feet isn't as stationary as we might think. Ever wondered how a river carves a canyon, or why a mountain peak is so sharp? These questions take us to the heart of geology, to the processes of weathering and erosion that shape our planet's landscapes. Let's start with weathering. Imagine you're holding a rock. Over time, natural elements like water, air, and biological organisms can cause this rock to break down. This is physical weathering. The rock might crack and crumble, fragmenting into smaller pieces. However, weathering isn't just physical, it can also be chemical. Rainwater, for instance, can react with the minerals in the rock, altering its composition and causing it to weaken or dissolve. This is chemical weathering. Now, let's move on to erosion. While weathering is all about breaking down, erosion is about moving away. Picture a gust of wind sweeping across a desert, lifting grains of sand and carrying them off. Or visualize a river, its flowing water picking up sediment and transporting it downstream. And don't forget about glaciers, those massive bodies of ice that slide slowly across the land, scraping and gouging the rock beneath. All these are examples of erosion, the process that transports weathered material from one place to another. Through these processes, our landscapes are constantly changing, evolving over thousands, even millions of years. The Grand Canyon, for example, was carved by the relentless work of the Colorado River, its water eroding away layer upon layer of rock. The sharp peaks of the Himalayas are the result of both weathering and erosion, their jagged edges honed by wind, rain, and ice. So next time you marvel at a breathtaking cliff face or a meandering river valley, remember the sculptors of these landscapes. It's not just the work of water, wind, and ice, it's also the work of time, the slow and steady rhythm of our planet. Through the relentless work of erosion and weathering, nature sculpts breathtaking landscapes. Water, in its many forms, is a powerful force of change. Today we turn our attention to rivers and glaciers, two of the most prominent agents of change on our planet. Let's begin with rivers. These seemingly tranquil bodies of water are actually industrious architects, ceaselessly carving their paths through the landscape. Over the course of millions of years, their relentless flow sculpts deep valleys and canyons, creating stunning natural masterpieces like the Grand Canyon. But their work doesn't stop there. As rivers flow, they erode the land, picking up sediment along the way. When they reach slower, flatter areas, they deposit this sediment, creating fertile plains. It's no coincidence that many of the world's great civilizations have sprung up along rivers. Their sediment deposits make the surrounding land incredibly fertile, perfect for agriculture. Now, let's shift our focus to the colder regions of our planet and discuss glaciers. These slow-moving rivers of ice are equally potent landscape artists. Glaciers form over many years as snow falls faster than it melts, compacting into dense moving ice. As they slide downhill, they grind and carve the underlying rock, creating U-shaped valleys, cirques, and other distinctive glacial landscapes. But like rivers, glaciers also deposit sediment. This sediment, known as till, can range from tiny particles of clay to huge boulders. When a glacier melts, it leaves this till behind, often creating unique landforms, such as moraines and drumlins. These deposited materials enrich the soil, making it ideal for vegetation to grow. So whether it's the steady flow of a river or the slow creep of a glacier, water is constantly at work, shaping and reshaping our world. It sculpts our mountains, carves our valleys, and deposits the fertile soil that feeds our planet's diverse ecosystems. From the mightiest river to the smallest stream, water shapes our world in ways both subtle and dramatic. So, our Earth is a dynamic, ever-changing canvas painted by geological phenomena. The story of our planet is one of constant transformation. From the highest mountain peaks to the deepest ocean trenches, every corner of our world is shaped by the ceaseless dance of geological forces. Imagine Earth as a colossal sculpture, meticulously crafted over billions of years. At the heart of this process are tectonic movements. These are the master artists, chiseling the planet's crust, building the grand mountain ranges, and carving the deep oceanic trenches. They're responsible for the land beneath our feet, the islands in our seas, and the continents on our maps. But the story doesn't end there. Once tectonic plates have done their work, the forces of erosion and weathering take over. Erosion is like a meticulous cleaner, sweeping away the loose rocks, while weathering acts as a relentless sculptor, breaking down the hard rock into soil. Together they shape the contours of our landscapes, from the jagged cliffs to the rolling hills. Then we have rivers and glaciers, the diligent transporters in this geological ballet. Rivers cut through the land, carrying away the eroded material and depositing it elsewhere, creating fertile plains and dramatic canyons. Glaciers, on the other hand, are the planet's bulldozers. They grind down mountains and reshape landscapes, leaving behind unique landforms when they recede, And so the canvas of Earth continues to evolve, shaped by these geological phenomena. It's an intricate dance, a symphony of forces that work in harmony to create the diverse landscapes we see today. As inhabitants of this ever-changing planet, we are privileged to witness its ongoing transformation, its perpetual motion. It's a reminder of the dynamic nature of our world, a testament to the power and beauty of geological phenomena. Next time you marvel at a majestic mountain or a sprawling plain, remember the incredible geological phenomena that made it all possible.